that if we have done crash dumped some part of the memory, this memory can be immediately allocated to the recovery VM, so that in a consolidated virtualized environment, which memory is a precious resource, so that you will not waste a lot of memory. Here is a picture depicts the flow of crash dump and the relocation of the memory. So we divide the memory in the crashed domain into a number of chunks. When the crash dump is in progress, we first crash dump some part of the memory into disk and then reallocate such memory to the recovery domain, so the recovery domain can be in the booting process, and so on, and this eventually the memory owned by the crash domain will be released to the recovery domain. As the memory of a crashed VM might not be in use, some part of the memory might not be in use. We also implement a selective dump by VM introspection. So the selective dump is based on an assumption that if the VM is crashed, the memory management data structure is still in an integrated state. This is a trade-off between the speed of crash dump and the safety of the crash dumped image. So we first access the memory of the crashed VM, extract the page descriptor array, and then identify the free pages. If such pages are free, we then skip such page during the crash dumping. Specifically, we introspect Linux memory map data structure and identifying the free pages by seeing if the count is 0 in the page descriptors. And in XC domain dump call by how callback, we skip such pages. We also implement disk I/O rate control by allocating I/O bandwidth between the concurrent call dump and the recovery virtual machines. Currently, we didn't implement a very complex policy, but instead allow users to specify the policy. For example, for an I/O-intensive virtual machine, like an NFS server, you can configure the such a virtual machine to allocate more I/O bandwidth. So this is a trade-off, actually a trade-off between the speed to release memory by call dump and the speed to boot the recovery domain. Actually, we are all already aware that there are some disk I/O rate control tools in enterprise virtualization products, like the IO-LIS and some kernel thread handling in domain UIO and domain 0. Sorry. And also we can have some alternatives like the scheduling hypervisor, which is open system agnostic, but we currently didn't implement a very complex policy. Okay. We have implemented a prototype based on Zen, and the code is around 800 lines of code in Zen tools, and also other hypercode to break the tie of the memory ownership between the crashed VM and the recovery VM, and we modify around 150 lines of code in Zen, and we didn't modify the guest operating systems. So we have some preliminary results on our optimized crash dump scheme. Our test environment is based on Zen 3.30 and Debian Linux with kernel version 2.6.28. We use the TBC W Java-based implementation, and the machine is a core Intel Core Dual 2 machine with 2 GB memory and 320 SATA disk. For the memory allocations among the domains, we allocate 512 megabyte memory to domain 0. As we only have 2 GB memory, so we allocate 1 GB memory to the production VM. You see, if we did not want the crushed VM to relinquish its memory, we cannot start another machine. So in our test framework, we can still start another virtual machine even if the memory is not enough. We disable ballooning in our testing framework, and we modify the TBCW implementation to record the moment of start and ending of crash dump. So the downtime is the end of recovery and the start of dump. And we also monitor the resource consumption during the crash dump process. So first, we measured the effect of concurrent code dump and recovery. The y-axis is the downtime, and the axis is different configurations. The first one is the baseline, is that the vanilla Zen without our optimizations, and it takes around 42 seconds to finish the crash dump and the recovery. And in our optimized version, the downtime is around 20 seconds, so it's an improvement of nearly 1 time. Also, we monitor the resource consumptions during the crash dumps of the machine. So the y-axis is the memory consumption of each domain, and the y-axis is the time. So this line is the domain 0. You see the domain 0's memory is constant during the crash dump. And the red line is the virtual machine to crash, and this line is the recovery virtual machine. As you can see, the memory reservation of the crashed virtual machine eventually decreased to 0, and the memory of the recovery virtual machine eventually grew up. And so this line time span is the total time of the crash dump, and this time is the recovery time. So this time is the downtime, including the starting of the recovery virtual machine, and the recovery virtual machine is ready to serve the services. Okay, we also investigate the effect of selective dump, and in this case, if we do not use crash dump, it takes around 45 a second and